Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
We've been calculating area with curves for a while now, and notice we've been using a single curve. But what if we had an area between two functions? So here I have a sketch made for you. I have an f of x function and I have a g of x function. And the question is, what's the area between those two functions on this interval a to b? Well, let's look at it a little bit conceptually here. You might have some ideas. I know you've written down some stuff from your notes, but let's look at it from a geometric perspective, and then maybe this formula that you've written down will make sense. If I want the area between two things, essentially I could take the area from the x-axis to the outermost function and subtract it with the area of the lower function with respect to the x-axis. So if I take the total and I subtract out this area right here, I'll get the area that I want. So what does that look like with integrals? Well, let's start drawing some rectangles. If I want the area up to the f of x function here, right, there's my rectangles, I'm going to do the integral from a to b of f of x dx. So this will give me the area from my function to the x-axis. Okay, but I don't want just that. Remember, we want this area here. So what we're going to do is we're going to take this area below and we're going to subtract it. Well, that's the area between the g of x function and the x-axis, right? So if I have this whole piece, if I subtract out this piece, then I get the area that I want. Well, what does that look like? Notice they have the same exact bounds and they're both with respect to x. So you remember your integral properties? We're so used to taking integrals apart. You can take these and put them together. So this is the formula that you have written down, hopefully from your textbook notes. But essentially, if you want the area between two functions, you're going to take the function that is the farthest from the x-axis, or the upper function, the upper bound, subtract it with the lower function, or in other words, the function that's closest to the x-axis. If you find their difference and then do your integral, you end up finding the area between those two curves. You're probably wondering, well, what if the second function is below the x-axis? Is that still going to work? Well, let's try it. Essentially, I want the area above the x-axis, which is just going to be the integral of f of x dx. But then I want to add it with the area down here, right? Okay, so that way the areas together will be the total area between the two of them. So let's start with the upper one. Now, if I calculate this, though, I'm going to run into a dilemma. If I add this together, so this is still the integral from a to b of g of x dx, we have a slight issue. That's going to be negative area, isn't it? Now, negative area is okay if that's what we want, if we want like the net result of something, but we don't want that. We want the total. So what we can do essentially is we can negate this. And now we're right back where we started. So it's still going to work whether it is, if one of the function is below or above the x-axis. You still can apply the same value. Now the difference here though is, remember, the first function is the upper bound, is going to be your function above the x-axis, and the second function is going to be the function below your x-axis in this scenario.